This lesson is about solving equations that have variables on both sides of the equation. So I'm going to show you this first one using these, they're called algebra tiles, and they're just sort of a visual way of seeing what's going on here. So I have two x's on one side, and I know those two x's are equal to an x plus 5. So here are my two x's, and I'll make an equal sign. And I know my two x's are equal to an x and 5. So I'm going to sort of split these up a little bit. I'm going to say two x's equal an x. And I'm going to put these 5 down here. Now, maybe you can see what I'm doing and maybe not. If these x's are equal to each other, which I know they are, then what does that mean? Well, it means this x must equal these 5. So really, x equals 5. Whatever this x was representing, it equaled 5 of these blocks. Because this x equals that x. There's no question about that. So this x must equal those 5. So that's sort of the way you should be thinking about this. Now there is the abstract way of thinking about it, and you might know this already, but this is sort of the visual way of thinking about it. You could also say, we just want to know what x equals. So we want to get rid of everything except x. We want to get all the x's on one side, everything else on the other side. So we're going to subtract x. So it gets rid of that x right here. Get rid of it. Well then 2x minus x is just 1x. And all we have over here is 5. So 1x is equal to 5. You get the same answer, and actually this is the way we're going to want you to do it pretty soon. But if you understand it this way for now, that's okay. So let's think about this then. If we have 4 x's, whoops. No, they're supposed to be the same size. Those are my 4 x's. And that's equal to 2 x's and plus 6. Well, you can see when I have the same thing of anything on both sides, really you can just get rid of that. So really we're going to subtract 2x from both sides. Really my equation here is 2x equals 6. That's really all that is. And why don't we split up this 6? Let's make it 3 and 3. Why would I do that? Well, because now you can see that x goes with 3 and that x goes with 3, so x must equal 3. And that's the same thing as dividing by 2 here. When you divide by 2, 2 divided by 2 is just 1x equals 3. So the same thing if you're doing it with the visual representation or with actual algebra. One more on this slide. We have 3x's equal x plus 16. Well, because both sides have at least an x, let's get rid of an x from both sides. That just leaves us with 2x's over here and equal to 16. Well, if 2x's are equal to 16, then 1x must be equal to 8. Half that. Okay, here are a couple of great websites that can just have a whole bunch of practice problems, and not only that, but they actually help you to understand what's going on. So the first thing it wants you to do is drag these things over. So on the left side I have 3x's plus 1. So I'm going to move 3x's plus 1 over here. On the right side I have x plus 5. So I'm going to move an x and 5 over here. And there we go, it's balanced. We're going to continue. And now we have to get rid of something, add something, subtract something, multiply or divide both sides by something. Well, you see that they both have a 1 block, at least one block. So let's get rid of one of those. Alright, I got rid of that. Well, now on this left side, it has 3 x's, and the right side has 1x. So let's get rid of an x from both sides. There we go. Now we only have x's on one side, and we only have 1's on the other side. So let's divide. How many x's do we have? We have 2. So we're going to divide by 2, and we get x equals 2. And that's it. So that's the whole idea. We're going to do one more. The whole idea is to only have x's on one side, only have 1's on the other. So here we have 2x's plus 3, and here we have 5. Okay, we're going to continue. And see how both sides have 1's. Well, let's get rid of as many as we can from the side with the x's. We can get rid of 3 of them. Alright, now that side only has x's. How many does it have? It has 2. We'll divide by 2. X equals 1. And this other website deals with some negatives, which pull the scale up. So negative 3x's are like balloons that pull the scale up. Plus 4 equals an x minus 8. There we go. Let's continue. Okay, well they both have what? It's kind of tough to see what they both have, isn't it? Well, it looks like they, the right side has an x and it has some minus 1's. Let's get rid of that x. Let's subtract the x from that side. Okay. So now that side only has 1's, or negative 1's in this case. Well, the left side almost only has negative x's, but it does have some 1's. So let's get rid of those 4 1's. Oh, okay, we can't subtract 4 on this website because it won't fit on the scale. So instead, let's do this the other way around. Let's add 4 x's to both sides. And now let's add, what is that, 8 1's? Let's add 8 1's to both sides. Okay. I guess this problem's too big for this website. Let's try something with smaller numbers. Here we go. Okay, we have negative 3x's plus 5. And then we have a negative 1 on that side. Okay, for this one, we want all the x's on one side, all the 1's on the other side. Let's move, since we have all the x's together, let's move all the 1's together. Let's subtract 5. That moves all those 1's over here. And now we have 3 negative x's. So we want to divide by how many x's? Negative 3 x's. When we divide by those, we get x equals 2. Okay, hopefully this visual representation helps you understand the algebra a little better. But at some point, we want you to just be able to get to this step right here and just be able to do it algebraically. Alright.